Hello, and today we're going to learn how to use the law of sines to find side lengths in a triangle. And this could be any triangle, not necessarily just a right triangle. Let's first take a look at what the law of sine is. The law of sine states that for any triangle that we would label with the vertices of capital A, B, and C, and then the opposite side lengths being lowercase a, b, and c, where side length C is opposite angle C, side length A is opposite angle A, and side length B is opposite angle B. So they're all in opposite configurations. The sine of any angle divided by its opposite side is equal to the sine of any other angle divided by its opposite side. And this is a statement of equality. Now, when you're using this to solve for a side length, you would usually only use two of these three pieces of the equation. We're going to practice setting that up. Okay, so when do you use this? You use this when you know two angles and one side, and you're trying to find one of the other two side lengths of a triangle, or both. Let's take a look at the first example. First example here, we have two angles and a side length, and we're trying to find another side length. So we can use the law of sines for that. All right, let's take a look at how we're going to pair things. So we have to use opposite angle and side length. So 80 degrees and x go together. Okay, so let's write sine of 80 degrees divided by x, okay? And then the 19 centimeters is opposite the 52 degree angle, so we can say that that's equal to sine of 52 divided by 19. Okay. Now notice we have one unknown, which is good. That's what you want if you're trying to solve an equation. And we have a proportion, so we can cross multiply. So we get x times the sine of 52 is equal to 19 times the sine of 80 degrees. Okay. All we need to do to isolate x is divide both sides by the sine of 52, so we get 19 times the sine of 80 divided by the sine of 52, and you can plug that right into your calculator, assuming that it is in degree mode. Please make sure it's in degree mode because that's the units we're using for angle measurements, is degrees. And you should get that it's about 23.75 if you round it. 23.75. The units on that would be centimeters. And there you have it. You can solve for the side length of any triangle given two angles and another side length. Okay. Let's take a look at another example. In this case, I gave away a little bit of it beforehand. Just pretend like you didn't see that. In this case, we're given two angles and a side length, right? And we have one side length we're trying to find. But notice, not only do we have an unknown on this side length, we also have an unknown for this angle measurement here. Whenever you pair up angle sides that are opposite of each other, and you want to use the law of sines, you need to know one or the other. In this case, because in this tutorial we're only solving for side lengths, you need to know the angle opposite the unknown side. In this case we do not, but because we know two angles in a triangle, you can find the third using triangle sum. This is 20, this is 55, so that's 75 degrees total. They have to add up to 180, so we're missing 105 degrees, which has to be the measurement of that angle right there. That's where it comes from. Okay, so now we can actually pair these up. The unknown is paired up with the angle opposite it, which is 105. So the sine of 105 divided by x is equal to. We could do the 20 in this side, but we don't know what the side length is, so we are introducing another unknown. Let's not do that. Let's pair the 14 and the 55 because we know both of those values. So sine of 55 over 14. Sine of 55 divided by 14. And now again we have just a proportion which we can cross multiply. We have x times the sine of 55 degrees is equal to 14 times the sine of 105 degrees. Again, we can isolate just by dividing both sides by the sine of 55, so we get 14 times the sine of 105 degrees divided by the sine of 55 degrees, and we can plug that into our calculator, again, as long as it's in degrees, and we'll end up getting that it's about 16.51. The units on that would be inches, so there we have it. We can find that missing side length there. This little key right here, the little using the triangle sum theorem, is what's going to allow us to solve for any of the side lengths that we want to, given two angles and one of them. In this case, we're asked to solve for the triangle. What that means is we need all of the missing angles and all the missing side lengths. The missing angles isn't too big of a deal. We have two angles, so we can figure out the third by using triangle sum. That would end up being 140 degrees. Okay. Now we're missing these two side lengths, so I'm going to call this guy x, and I'm going to call this guy y. Okay. So we need to set up two different law of sine problems in order to solve this. No biggie. In both cases, we're probably going to use this because it's an opposite pair that we know both of the values. So we're probably going to want to take advantage of that information. The sine of 140 divided by 50 is equal to, and now we have an option. Do you want to solve for x or y first? I'm going to assume that the audience is very alphabetical and wants to take care of x first, so we're going to pair up the x with the angle opposite of it, which is 30 degrees. So sine of 30 divided by x. You cross multiply, you'll get x times the sine of 140 is equal to 50 times the sine of 30. So when you divide both sides by the sine of 140, you can then isolate x, and then this would be something you'd plug right into your calculator. Again, making sure it's in degree mode. 50 times the sine of 30 divided by the sine of 140 is about 38.89. And again, the unit on this would be inches. Okay, so there's x. Y, again, because we would, and that, by the way, that's the letter y. The letter y would be, we were going to still use this pair right here because we know the values. So sine of 140 divided by 50 is equal to, and then the angle opposite y is 10 degrees. So sine of 10 degrees divided by y. Cross multiply, we get y times the sine of 140 is equal to 50 times the sine of 10. And when we divide both sides by the sine of 140, we get 50 times the sine of 10 divided, oops, sorry, the sine, moving stuff around on you. Sine of 10 divided by the sine of 140. And if we plug that into our calculator, we'll get that y is approximately 13.51. And again, that's yards. No, that's inches, sorry. I don't know what problem I'm in. We notice we can actually solve for all sides of a triangle and all angles of a triangle given just two angles and one side length using the law of sines. It's a very helpful tool. There's another instance where you can use the law of sines. It's the next video. It's a little bit more complicated, it's a little more complex. So I'm going to leave that for the next video, and for right now we're just going to leave this one saying that this is how you can use the law of sines in order to find a missing side length giving two angles and a side length already.